So today we are going to learn a very important drug which is studied in medicinal chemistry, that is benzodiazepines. Okay, so before we are going into the depth, first if we break the name benzodiazepines, then what we will get in this: benzo means benzene, di means 2, aza means nitrogen atom, and ep means 7 atoms. Okay, so what does benzodiazepine consist of? It consists of 7 atoms, 2 benzene ring, 2 nitrogen present in the 7 atom. That is, the structure is like this: benzene, so nitrogen. So this is the 7 atom structure. Along with this, we will get a benzene ring attached. So okay, and along with this, we will get another benzene ring attached. So 2 benzene ring. In this benzene ring, one R will be there. Sorry, in this benzene ring, one R group will be there. In this benzene ring, one R group will be there, and in this one R group will be there. One carboxyl group is there, and another R group is there. Okay, so this is the complete structure of benzodiazepines. The most important point you have to remember is benzodiazepines has 3 parts, that is A, B, and C. Okay. The second most important point you have to remember about benzodiazepine is this: benzodiazepine is nowadays used widely as sedatives. Okay, before that people used barbiturate, but now they saw that benzodiazepine is good compared to barbiturate because benzodiazepine increases the frequency benzodiazepine increases the frequency of chlorine channel. So it will open and close, open and close, open and close again and again. Chlorine channel, so increases the frequency of chlorine channel, opening of chlorine channel, whereas barbiturate increases the time duration of the chlorine channel. So because of that, what happens if barbiturate is used, then for more duration chlorine channel is opened and chlorine gets inside the cell. Okay, so when chlorine gets more inside the cell inside, then it so much amount of chlorine gets inside that this cell becomes hyperpolarized, and it sometimes leads to coma and death also. And the hyperpolarization leads to the inactivation of the CNS, which leads to the coma or death. So because of this, benzodiazepine is used better than the barbiturate. And if it is used also, it is used in very less amount, very less amount. Now I'm going to tell you about sedatives and hypnotics. You know what is the difference between sedatives and hypnotics? So sedative is the decrease sedative is the decrease in the hypertension or decrease in the excitement without inducing sleep, whereas hypnotics, see, sedatives are those drugs which reduces anxiety without inducing sleep, whereas hypnotics are those drugs which reduces anxiety but inducing sleep also. Okay, now we are going to see the SAR of the benzodiazepines. Before learning the SAR of the benzodiazepine, first we have to learn the different cyclic structure present in the benzodiazepine. The first cyclic structure, that is A, and is benzene ring. This benzene ring is attached with second B ring, that is 7 structure ring. Okay, so this is B, this is A, and C is again the another benzene ring. Okay, now in this we have to learn what are the different side atoms present, or what are the different side chains present. So the most importantly, first of all we have to number. So start numbering from n, because we know OSNP rule. According to OSNP rule, first we have to number the we have to start numbering from n. So 1 2 3 4 5 6 7 8 9. Okay, now we will see the most important point or changes in structure A, say, or acyclic structure. Okay, so in acyclic structure, the side atom which is present or side chain which is present, if it is more electronegative, more electronegative, that is, for example, take chloride or take nitro, then what will happen, it will increase the pharmacological activity, it will increase the pharmacological activity. So at seventh position, this is most important, at seventh position, that is in that carbon, if the side atom which is present is more electronegative, then it will increase the pharmacological activity of the benzodiazepine. Number two, if any substituents are present at sixth position, eighth position, and ninth position, that is C6, C8, and C9, then it will lead to the decrease in the activity of benzodiazepine. So any substituent present in the 6, 8, and 9 position, that is C6, C8, and C9, it will lead to decrease in pharmacological activity of benzodiazepine. Okay, after that we will see the changes in ring B. In ring B, the first point is nitrogen, that is first point in the first position. In the place of R group, if we put CH3, that means any alkyl group, any alkyl group substituted at the first position will increase the activity of benzodiazepine, it will increase the activity of benzodiazepine. Number second, that the substituent will lead to the decrease in the action of benzodiazepine, the duration of action of benzodiazepine, that is, it will make the benzodiazepine short acting when the benzodiazepine are having hydroxyl group at third position, if OH group is present here, if the hydroxyl group is present at third position. And number two, if the aromatic benzene ring is present at fifth position, that is fifth position. In this, if the R is H, in the place of R, if H is present, that means it will act as it is benzene ring na, and it will act as aromatic benzene ring, it will lead to the decrease. So that means this is aromatic benzene ring, and it will lead to decrease the duration of action, that means it will make it short acting. The benzodiazepine will act as short acting. What are the reason? Number one is if hydroxyl group is present at third position, and number two, if the aromatic benzene ring is present at fifth position. Okay, the next point is we are going to see the modification or changes in ring C, that is the C ring na. So in the C ring, what will happen, if any high electronegative atom is present in the ortho position, ortho position means second carbon. See, this is the ortho position, this is meta position, this is para position. So in ortho position if any high electronegative atom is present, then it will increase the activity of benzodiazepine. What will do? It will increase the activity. So the example of high electron, that is, you can take fluorine. If fluorine is present at ortho position of the benzene ring or C ring, or any high electronegative atom present, then it will increase the activity of benzodiazepine. Okay, this is the SAR for benzodiazepine. Now you have to remember that this benzodiazepine is most widely used. First point. Second point, barbiturate, less used, and benzodiazepine, more used. Okay, it has three ring, A, B, C. So you have to remember this. A ring is benzene ring, B ring is 7-membered ring, and C ring is again benzene ring. Okay, thank you.